Dial again. Good afternoon to all of you. I, Dr. L. Sivaram Krishna, coordinator of this program, along with Professor Sriram Ganesh, coordinator of this program, Atal AICT, sponsored 1 week online FDP program in 3D printing and design. Welcome you all for the session number 12, which is the most awaiting session of this entire FDP program, because in the last sessions, we had all the theoretical inputs required for doing 3D printing. Like yesterday, we had a biomedical session completely by doctors. They told how 3D printing can be used for biomedical. In that, Professor M. V. Reddy sir told how to do biomedical modeling, etc., explained you theoretically. But now that we are going to have a hands-on practice today on biomedical modeling using 3D slicer as well as STL file, how do you slice in the CURA software before you produce the part in the machine? Because as I said, 3D printing, all this preparation stage is very important. Designing and as well as setting the parameters before you print is very important. If you commit any mistake here, what happens is your final product will be an error. So this is a very crucial step in this. So we are joined now with by Dr. Manmadachari, and I am proud to say is my student in MTech and who has done such a hard work that I know how he developed himself, evolved himself from a person who is with a small background, but with intention is very, very big. You want to do something good, something better, so that you will have some recognition. So I think initial stages when Manamachari was there in our doing MTech around, I think 2008 or 2009, Chari were doing MTech production in 9. At that time, Professor Sriram Ganesh established the Center for Prototype Testing of Industrial Products. We have an SLS machine. So that SLS machine, we thought, why can't we use it for our MTech project work? Because at that time, very few people started using 3D printing, especially in academic, in doing some work. So Venkatesh sir, myself, Chari, we thought of doing work on biomedical application of 3D printing. So then he is the first person, I think, in our SLS center, student who was interested to do biomedical application. So we have done that maxillofacial application, the mandible application. And he has worked so hard. He was sitting with the machine, learned everything. I think he was nights also used to stay on the machine and used to make the models, everything. That's how he practiced using 3D printing. Then, of course, he has done very good work and which got published in a reputed journal after so many queries. After even completing his MTech, he was awarded excellent by the external examiner from NIT Warangal. But he said, you publish paper immediately. Chari sir, published paper immediately. He was interested to do it. After even MTech certificate was awarded, he still worked out because very few people have that inclination, and finally we could publish the paper, and that paper made him to get into NIT Warangal as a doctoral candidate, and he has done very good work under Professor Raikumar from NIT Warangal, and finally he got awarded his PhD degree with he's done excellent work in PhD work also. And because of his inclination to work in especially biomedical application, I am proud to say that he was called by Mr. Chua from Nanyang Technology University to speak in his international conference on 3D printing and design. And when he was about to go to Singapore, I think that is his first trip to the other country, he came to me and he told, sir, I was called to speak in that session. I felt very proud as a faculty, as a teacher. When a student grows to such an extent, we feel a lot of proud. And I think from then onwards, there is no looking back for Chari in his 3D printing work. That's why, if you observe our entire schedule, we have very experienced senior people in our schedule. We have middle experience, that is, people are having a little bit less experience, but with good in theoretical background. But along with us, we have the young people like Balaji and Chari, who are also doing wonderful work in their domains. So I have made them as one of the speaker because he is very good expert in biomedical modeling, etc. I welcome Chari to be a part of this session, and we are happy to have you here, especially on online, hands-on practice on this your 3D slices and CURA software. Now, I think all the participants are ready. We reached 100 now, right? We reached 100, so it's a good sign. So we can start our session. Now, on behalf of the department, on behalf of the Center for Product Design Development and Additive Manufacturing, myself and Professor Sriram Venkatesh invite you for this exciting journey of using these softwares for making the biomedical modeling, etc. So now I request Sweta to introduce the speaker to the audience. So before that, I would like to share his slide. So Sweta, please continue with your introduction part.
Yes, sir.
Amma, your audio again problem. Hello, Sweta, your audio is problem. Sweta. Hello. Your
Sir,
audio
I'm audible now.
No, it's staggering. It's staggering.
Yes.
Please proceed.
Yes. Welcome back to the session 12. I'm pleased to introduce Dr. A. Manmadachari sir, speaker of session 12, and sir will be handling online practice session on Bio-CAD modeling using 3D slicer and CURA slicing software. Dr. A. Manmadachari sir is presently working as assistant professor in the Department of Mechanical Engineering, ICFI Tech, Hyderabad. Sir completed his PhD from NIT Warangal in additive manufacturing, Masters from UCE-OU, and BTech from JNTU, Hyderabad. His areas of interest include 3D printing, optimization techniques, CAD/CAM, design and manufacturing of patient-specific implants. He has published more than 20 papers in various referred international conferences and journals. He completed the R&D project for Institution of Engineers, India. He achieved MEDIC 2018 Innovation Award from IIT Bombay. Sir has filed USA patent on implantable device for temporomandibular joint and method of production. He is working with MNR Medical College and Hospital, Panania Institute of Dental Science and Research Center for various critical cases through design and manufacturing of implants. I welcome you, sir, for the most awaited hands-on session.
Thank you, sir. Thank you, Shweta, for introducing.
I'm handing this giving the share option to you. Sorry, please continue.
Yes, sir.
It is over to you. Please continue this.
Yes, sir.
Now we are able to see your screen.
Okay. Good afternoon. Okay, this is Dr. Imam Achari. Today I'm presenting a presentation on Bio-CAD modeling and 3D using the 3D slicer and slicing software using the CURA. So
Please be little bit louder, sorry, little bit louder.
Okay, before going to my presentation, I'm giving a brief introduction outline of my presentation. Yeah, first, what is the definition of the 3D printing? Then, basic concepts, steps in 3D printing. Here, the STL file we are creating by using the three methods. One is from the CAD modeling, untracing from the medical data images. The third one is from the reverse engineering data. By using these three things, okay, we can create the STL file. Okay, I will give demo on how to convert from CAD to STL, how to convert from the diagram image to STL. Okay, the reverse engineering that how we will convert. Okay, tomorrow you are having the session, the reverse engineering process, using the 3D scanner. Okay, just I will give a small introduction on that one.
Please, you keep your mic nearer, sir. It's somewhat it's staggering of parts.
Okay.
It's not.
Okay. Here, then after creating the STL file, we are going for the slicing. Okay, how to do the slicing? Okay, how that is I'm explaining using the CURA software. After developing the slicing, we are going for the generated G codes to run the program, the 3D printer. That is also I will explain. Okay, how the G codes will be generated from the STL file. Okay, here almost 70% is the practical session, only 30% is the theoretical one. Okay, you know almost all yesterday onwards you are listening. Rapid prototyping and 3D printing is a technology to produce the physical models from the 3D CAD model or CT or MRI data or reverse engineering data. And here, by using these three different methodology, we are creating the objects. That means STL files. Okay, that's why we are going to deal in this session in this one. Okay, in the olden days, okay, we are this 3D printing and rapid prototyping is used only for the prototype purpose only. Now we are this function. Now this 3D printing technology parts we are using for the functional purposes. So with the automobile industry and aerospace industry also they are using. So that's why the ASTM committee the definition is changed. Okay, now the additive manufacturing is a process to make objects from the layer by layer upon to making a model, as opposed to the subject to the manufacturing process. Yeah, already you know this is the basic steps. Okay, the first we are going for the CAD modeling. From CAD model to we are going the STL file conversion. From STL file conversion to we are going for the slicing. From this slice data we are sending to the machine. So how we have to go for the CAD modeling the STL file? Okay, that is we are learning in here. Majorly for making a STL file we are having the three options. First one is the 3D CAD modeling. Second one is the medical scan data. Here third one is the reverse engineering. Okay, here in the medical CAD modeling, okay, nowadays in the open source libraries available, directly you can download through net or in the different websites. You can see a GrabCAD, ThinkSover, TrueSub printers, UMac. Okay. So many libraries available. From this library, directly you can download and you can print your model. Okay, now here, that is the one. Again, the second one, if suppose you want your own design, okay, that purpose we have to design ourselves. So majorly, okay, who are the without background mechanical people or without any technical people, you can design by using this software, the Tinkercad and SketchUp. So you don't need any basics. Okay, you don't need any CAD model, CAD fundamentals. Directly you can do your CAD modeling in this software. Suppose our mechanical engineers and civil engineers, architecture people, we are using these softwares, the PTC, SolidWorks, CATIA, IronCAD, the Solid Edge, AutoCAD, almost all they are we are using. The 3D Max software major this is using for the architecture people. Okay, yeah, nowadays, okay, this 3D printing and rapid prototyping is using in the film industry also. In the that people they are using the Blender, JetBrush, and Maya. Okay? The animation data you can convert the STL file, then the data you can create the 3D printed model. For that purpose, we are using these softwares. So when we are creating the CAD model, how we have to convert the STL file? So I will give the demo now. Here you can see these are the website how we can convert the CAD model to STL with using the different steps. If you want, you can download and you can extract in your own software. But here I'm going to give you a demo on PT Studio software, how we have to design and how we have to create the CAD model. Are you seeing my Studio software window?
We are able to see your PPT.
PPT.
You are able to see your PPT.
Okay. I want to stop it. Now, sir? Now you are seeing my screen?
We are able to see your
Software.
that is software PLC, outdated CAD tools.
Okay. Okay, now I'm giving a small demo here. How to convert the CAD model to STL file in the CAD modeling techniques. Okay, first we are going to just I'm taking a small cube here, just to fun part. MMS Power Solid. So just I'm going to do some small block. Just I'm changing my dimensions here. Okay, here is extrude. Okay, already you know some people. I'm doing the extrude. Extrude means that I'm creating the one plane with adding some thickness. Okay, this is the CAD model. Okay, from this CAD model, how we have to convert the STL file, I'm showing to you. Next file, save as. Just go for the save as. You are going for the different file formats are available here in your software. One of okay here you can choose stereolithography file. The STL full form is the stereolithography file. Just I'm clicking here. Then I'm clicking here. The part 1 is already exists. Continue anyway. Okay, I'm clicking 1. Here you can see here. This window will be appear here. Okay, here when just I'm clicking apply, then okay, you can see here the totally object. Okay, the surface are dividing by the triangles. You can see this is the surface. This surface is divided the two triangles. Here 6 surfaces are there. These 6 surfaces is divided in the 12 triangles. Okay, that you can see here. The two, suppose this cube. Okay, we are creating the 12 faces. Faces means one triangle. Okay, here total 6 surfaces are there. These 6 surfaces, okay, we are divided in each surface. We are divided two triangles. Okay, that's why we are getting the totally 12 triangles. That means 12 faces. The same. Okay. I'm going to do here one more object. I want to make a one sphere. Just go for the sketch. Operating. I'm choosing this plane. Then after I'm going for the sketch view. Then I'm taking a center line. Okay, to create the sphere, you have to create a one semicircle. On that semicircle, you can rotate through the axis. Then you can create the sphere. So this is the sphere object. Suppose I want to make a STL file here. Okay, here the same thing, file, save as, same thing, STL file, STL. Then click here, okay. Just once again I'm creating. Just click here, apply. Okay, you can see here this is total surface. How it is divided into number of triangles. You can see. But when you are seeing here, okay, this surface is not smoother and it is not uniform, and you can see here some edges are having some roughness. It is not inclined. Exactly, you can see. You can identify the deviation. Okay, this whatever this is showing here, this green color actual curve. This red color is the tessellated curve. That means when we are creating the triangle, okay, this red is the triangle curve. So here some deviation is there from this green color to this red color. Okay, this deviation we are representing as a chord height. Suppose you can see here. Okay, here this is the curve or the circle. When we are creating the STL file, the surface, everything we are tested by the triangles here. So when we are creating the triangles, it is having the one straight line. Actually, our object is having some curved line. So the difference between these two we are representing as a chord height. Okay, this one is the chord height. Okay, the angle between of this edge to this curve, that is we are representing the angle control. Okay, these two options you have to ensure when you are creating the STL file from the CAD model. Here, different softwares are having the different option, but you have to choose the minimum chord height and minimum chord angle. Suppose, okay, now I'm giving something. For that, I'm giving the 0. It is not taking the 0. It is taking some 0.06. Here also, I'm giving the 0. It is not taking the 0.05. Now, it is taking something 0 into 10 power of minus 9. Okay, how much that value is that is taking. Okay, now click and apply. Now you can see how is it. Now the object is good, and the deviation from this green line to this red line near to closer. You can see here. Okay, this is very important when we are doing the CAD modeling to STL file. Okay, you are doing the design properly. Suppose you are not saving proper STL file. Okay, maybe your object is not smoother, not good. Okay, before going to convert the STL file, you have to ensure all these options and you have to create according to your. The one more option is the step size. The step size means when we are creating the object, the total object you can see here, how many number of steps are there here. This is a one step, 1, 2, like this. The slice, this is the lines in the on the ball. Okay, you can see 1, 2, 3 lines. The different steps are there. So the different steps you can control by using the step size. Suppose I'm giving the 21.143. Just you can click apply. Now you can see how is there. Suppose I'm giving one more 30. You can see the number of steps are increasing. Now before you have to convert the STL file, you have to reduce the as much as chord height and as much as chord angle and as much as minimum step size. And one more option also there, the binary file and ASCII file. Already you know. The binary file is the machine readable file format. The ASCII is the human readable file format. Okay, when we are saving the file format in the ASCII, you are getting the more data. When we are saving the binary data, okay, the file getting the lesser data. So before going to convert the STL file, you have to choose minimum chord height, minimum chord angle, minimum step size, and okay, for sending the file to reduce the size, you have to use the binary file format. These options are required. In the CURA, these options are there. Suppose you are going for the SolidWorks, they're also having the different angle variation option is there. There are different softwares having the different options. But okay, this is the okay, this is the conclusion. The conclusion is you have to reduce the chord height, you have to reduce the angle control, you have to reduce the step size. These three things you have to ensure when you are converting the STL file. You can see here totally okay. When I'm giving the less step size, less higher step size, higher chord height, and higher chord angle. Okay, the total sphere is changed. You can see very irregular shape. When we are choosing the medium parameters, you can get a accurate or the nearly accurate model. When I'm taking the lesser values, you are getting the perfect model. So these all the options are required when we're translating the CAD to the STL file. This is about the theory. Okay, what is the STL file? Okay, I'm telling always STL file, STL file. So when we are converting the object, the totally surface is divided into number of triangles. Each triangle, okay, that is called the vertex. That is each triangle having the points. These points, 1, 2, 3 points. But that is called the vertices. Now these 2 points we are joining by the edges. So 1, 2, 3, 3 edges are there. Okay, this totally we are representing the one face. Here is one. So when we are converting the STL file, okay, it is having a thumb rule. Always the object or the unit normal vector is moving from the inner to the outer side, and it is the counter clockwise direction. It is rotate. The direction is there. How we have to represent this? Normally, this STL file. Okay, how we have to represent the normal vector? So we have to represent the vector by using these edges. I'm taking the v1, v2. Okay, I'm taking a 1a vector. Okay, when we are using these 2 points, you can create a vector. Here also, when we are using these 2 points, you can create a vector. Okay, I'm taking this is the a vector. I'm taking as this is the b vector. Because the formula is equal n is equal to a cross b by under root of a square b square minus a dot b. Here is the cross product. Here is the dot product. When we are doing the multiplication in the vectors. Okay, that is the STL file representation. So while I'm explaining this, means when we are doing the research, this representation is very important. Based on the STL file, you can create, you can edit, you can write your own code. So that's why I'm explaining. So when we are doing the slicing, how we are doing the slicing and the STL file, I will inform to you. That's why I'm telling this theory. What is the structure of STL file? Okay, you can see that this is a unit normal vector. This is an outer loop, this is an end loop. In between having the two vertex, the vertex 1, vertex 2, vertex 3. These three vertex we are representing. But this is one triangle. Like that, how many triangles are there? That much facet normals are coming and save this vertex representation. In the previous case, you are seeing, okay, there's 12 facets for the cube. When I'm seeing the sphere, you're having so many facets. The second one, okay, still now you learn how to convert the STL or how to convert CAD to the STL file. Now I'm going to explain to you how we can convert the STL file from the medical data. So here in the medical imaging, we are going to do some scanning. Okay, in the nowadays, okay, for diagnose the patient, they are using the CT scanner. So not in the medical community nowadays in the industrial, the non-destructive testing purpose also. Now we are using this CT scanning process. Suppose okay, this is like a casting process. In this casting process, well, suppose some blowholes are there. Where is the blowholes are there? Okay, we have to find. And that case, the researchers are doing the scanning of this object and they are making a CAD model. Then they are going to slicing. In each slice, they are checking where the hole is there. Then we can identify without any disturbing the part. So that purpose we are using the industrial CT scanner. Okay, and in our medical community to diagnose the patient and to design and manufacturing the implants purpose, we are using the CT scanning. Okay, in the CT scanning, we are generating the diagram images. How the CT scan is working, I will explain to you here. The patient is lying on the table. So here, one side having the X-ray tube, another side having the detectors. When X-ray tube is rotating, okay, this X-ray tube is giving the X-ray beams. These X-ray beams are detecting the detector, and okay, this X-ray tube is passing through the patient. Then it is detecting the detector. When the X-ray tubes are passing through the patient, okay, based on the density of the part, the different part having the different density. So based on the density, the detector is taking the anatomy. So when we are using the thresholding values, okay, in the CT scanning also they are setting the threshold values. When we are setting the, suppose I want to require the bone, the bone to threshold value for the CT scanning plus 226. They are setting the plus 226 value. Based on the that value, the X-ray this detector detects that beams when they pass into the patient. Okay, when this rays are passing from the X-ray tube to the detector, okay, we are generating the images. Really, the doctors, okay, they are, wherever the problem is there, the tissue they are identifying, and okay, they are printing, and that printing report we are giving by the film. Okay, you are seeing outside. Okay, but as a engineer, suppose you have to do implant or you have to do some design, we have to take all the images. Suppose this body is there. Suppose when we are going to scanning of this skull, okay, here minimum, okay, minimum it is taking the 150 images. 150 images you have to collect, and that 150 images you have to reconstruct in your software. Then you can get the CAD model. Okay, now tomorrow yesterday I forwarded to you the diagram images. Okay, that is the one single skull image. You can see nearly 146 images are there. Okay, how it is working here? Okay, when the X-ray tube is moving, okay, the X-ray beams are taking here whatever the minimum or the thickness. This thickness also you can set in your X-ray CT machine. And majorly we are using the 0.625 mm thickness. It is taking. So the 0.625 mm tissue is detecting the detector when the X-ray beam is passing at the single time. Then it is rotating one layer by another layer. Then each layer you have to collect by using this detector. These images we are storing in the computer by using the image processing algorithm. So you can see here, okay, we are having the one tissue here, or one layer of the tissue. This layer having, okay, you know the pixel. The pixel means only two-dimensional element, but here having some thickness here. Okay, now this pixel is changing in a voxel. Voxel is the three-dimensional element. Here, different voxels we are collecting in the by using the different detectors. The detectors having so many number of small blocks. In each block, we are collecting the each voxel. Here, these voxels. These voxels we are framing. Okay, just when we are rotating, you are getting this type of voxels. These voxels are framing based on the threshold value. The threshold value we are setting in the CT scanner. Okay, whatever the threshold value is there, based on the density, you can extract the anatomy of the patient. Suppose I require only 226 for the value. I'm setting the 226 value in the CT scanner. What happened here? The remaining the 0 to 226 value is eliminating here. These voxels. Only these voxels only you can reconstruct by using your algorithms. And like that arrangement is there in the CT scanning process. Okay, now this each slice. Okay, these slices we are taking and we are going to process the 3D CAD model. You know the major how we have to generate the mental model. Well, this is the basic steps. First, we have to go for the CT scanning. In the CT scanning, we are developing the images, diagram images. The diagram images we are going for the processing by using the softwares. Okay, Mimics and 3D Doctors, this is the commercial softwares. Now I'm giving the demo on the 3D sensor how we have to convert from the diagram image to the CAD model and to convert the STL file. And then
Chari, can you switch on your video? Please switch on your video.
Okay, okay.
Yeah, please continue.
Okay, sir. Once one STL file is generating, automatically you can manufacturing and you can do your applications. Here, we are going to deal in this session how we have to convert the diagram image to the CAD model and STL file. So nowadays, so many softwares are available to create the diagram to CAD or STL file. 3D Slicer, Invaslevs, Meanwise Lab, ITK Snap. So these all are the open source softwares. Okay, you can get freely. You can do process without any cost. Suppose Mimics, 3D Doctor. Okay, these are the commercial softwares. Yeah, but it is accurate compared to this one. That is the major disadvantage, and that is a major advantage. This is a less cost. This is a higher cost, but this is accurate. This is a less accurate. Okay, how we have to convert from the diagram image to CAD model? I'm giving you demonstration of here. First, we are this patient. We are lying, and we are taking the diagram images. That diagram image I'm importing into in our software. Okay, here the 3D Slicer software is there. I'm already posted in the mail. Okay, here this is the 3D Slicer software. When we are opening the 3D Slicer software, you can see this type of window here. Okay, here first you have to go for the load the diagram data. Next, import the diagram images. When the images are there, that is you have to extract here. Suppose my images are there on the desktop. On the desktop, I'm going and then I'm importing. Now you can see here the images are importing here. Okay, here you can see the input completed and one patient, one study, one series, 136 instances. That means these slices are there. So now I'm going for the patient. Just I'm selecting here. You can see how many images are there. 136 images are there. Each image size is 5 divided by 5 sizes. That means this is the pixel size. Okay, for the length 512 pixels are there, and the width also 512 pixels are there, and that the tissue is inserted. That is representing the size of the tissue here. Okay, each tissue having one slice. Here we are having a 136 slices. So these 136 slices I'm importing into the 3D slicer software. Okay, you can see here, these are the diagram images. Just you can go for the here, just when I'm moving this cursor. Okay, here this is the bottom layer. Okay, when I'm moving from another side, you can see, okay, oh, this is the bottom is the chin here. Okay, I'm taking the image of the skull. Okay, this bottom layer having the chin. Now I'm going upper. Okay, now you can see here. Okay, you can see here. Yeah, now it is moving from top to bottom. So bottom to top. These are the teeth. These are the maxilla. These are the nostrils. Okay, here also you are having the three views. Okay, as our mechanical terminology. Okay, this is the top view, the side view, this is the front view. Okay, the doctors they are telling this is the anterior and posterior and sagittal views. Okay,
So axilla, corona, and sagittal, no?
Sagittal, yes, sir. Sagittal views.
Can you show? I think in others or in Invacillus, you will get the bottom right corner becomes a 3D, that 3D image.
Nice, sir. Yeah, here also is coming. Just I will fix.
Yeah.
Okay, now the here also having the different modules. Okay, now here you can see this is a diagram module. In the diagram module, we can extract and we can import the diagram image only. Here different modules are there. Now we are going for the volume rendering. So here now I'm creating the volume. You can see this symbol. Okay, what I'm showing in the PPT. Okay, here. Okay, you can understand. It is totally tissues. Whichever the part is required, on that part we are applying the threshold. Then you are getting the our required object. Same thing here also. In the volume rendering, okay, we are going for the thresholding, exactly speaking. Okay, we can extract our required object. Okay, now, okay, the volume rendering ourselves. Now we are view the volume here. Now we are enable crop and display. Okay, this is the patient data here. Okay, here you can extract whatever the object is there that you can extract here. Okay, you can see here. We are having that so many options are available here. This is a CT, and this is a CT board. This is a CT cardiac. Okay, suppose you are working on the cardiac patient, you can go for directly. You can choose this option. Okay, here this is a cardiac. This is a chest. Suppose you require the chest, correct? You can take. So these automatically predefined threshold values are available here. In some softwares, you have to apply the threshold based on the density of the object, the tissue. Here you can see this is also coronary. This is the artics. This is the cropped bone, and this is a liver. Suppose you are working on the liver, you can directly choose this option. Okay, this is the CT MIP, and this is the MRI data. Suppose you are using the MRI data, directly you have to select this one. And this is the MRI angiography. Angiography means just we can extract the nerves only. And this is only X-ray. I want only X-ray for the tissue. That also you can extract here. Here CTA. Suppose only airflow analysis they require. Suppose gastric problems are there, and that we are using some CT air analysis. Okay, that also we can do. Here the predefined library is directly available. In some softwares, you have to define your own. I suppose my area of the industries, I want to extract the CT bone. Okay, I require only bone. I want to modeling a, I want to manufacturing a maxilla and mandible bone. That is my intention in this case. So that's why I'm selecting the CT board here. Thereafter, you have to choose this options. That means you have to choose the threshold value based on this cursor. Okay, you have to extract this cursor. Okay, then you can see here. Okay, in the previous how is there something bone is visible. Now it is not clear. Something you have to move. Okay, something you have to shift this cursor. Okay, this bone will be appear here. Like that, you have to play something. Then you can extract the actual bone here. Okay, these are this is the CT plate. When we are lying on the CT scanner, here the backs are having some plate. So that's why you can see in the CT scanner. I don't want that plate, so that's why I'm removing in the 3D modeling. Okay. Now almost all good. Something little bit errors are there in the outside. That is I'm going to extract here. So now it's good. Here, okay, now okay, we are okay, we are identify the bone by using the volume rendering. Okay, here I require only some of the portion. Okay, I don't require this maxilla mandible. I require only some portion in this one. I require only this much portion. So I'm going to small process. I'm going for the cropping. Go for crop value. Yeah, just I'm going for the crop value. Now before crop value, okay, we have to adjust the cropping here. Okay, where we have to extract the cropping. That means where we have how much volume you require. That is, you have to adjust in the each and individual uh, plane. That means each and individual side. Okay. When I'm adjusting here, automatically you
Sorry,
can see here.
will you have to follow your lecture now, or you will be explaining again in by step by step?
Yeah, already step by step is there, sir. Okay, when we are doing the processing, I will do it. That means I will explain once
Now,
again.
after this demo, again you will explain them, or they have to follow no one along with you, no one.
Yeah,
Some people are
once again,
asking,
uh,
some
once again,
participants are asking, participants are telling unable to get the skull image, sir. They are telling.
okay, once again I will do, sir, because okay, so many problems are coming in the online. So once again we have to go one by one. Yeah, my intention
Okay.
is okay. We have to first we have to give the theoretical part. Then we
Okay.
are
Right.
going for the one.
So after
What
this
do you want?
theory, again you will be
Ah,
explaining them. Right.
yes, sir, yes, sir.
Right.
Actually, here
So
I'm
other
telling
participants,
okay
please
how we
wait.
have to extract. Hmm.
Yeah.
If you want, I
Start
will
now.
go.
Yeah. Chari is
Sir,
now Chari is now explaining the theoretical part. Afterwards, again you will start from scratch. Is it right? Right.
yes, sir, yes, sir, yes, sir. If you want, I will do here onwards. Understand now onwards.
Now onwards you can do, I think, because we'll be saving time.
Okay.
Otherwise, sir, one question was is I have done same thing as you said, but didn't get 3D model. What would be the problem with us?
Okay. Actually,
Are you
I
able
will
to, are
do.
you able to see the chat box? Are you able to see the chat box? Sorry.
Okay. Okay. Chart. Okay. Chart box. Yeah. Unable to
Please.
get the skull image, sir. Oh, that is it. Okay. Sir. Yeah. Now
First,
I will
let
give the.
Sari explain. Chari explain the fundamentals. Then you will again start from scratch. You will start
Sir,
completely.
actually, sir. Okay. Now we will
Please
go
continue.
for. Okay. Okay, here I'm telling how we have to do extract and what is the theory, which volumes are using. The next, I will give only step by step using our manual. Okay, now I'm cropping the images. Sir. adjusting here in this case. Here also I'm adjusting this side. Just you have to put this pointer and stretch this side. Then automatically it will be cropped. You can see in the different view, you can extract the bone. Okay, here I'm looking only for side view. Okay, I don't require this bone, this spinal cord. So that's why I'm removing here. There's something here, bone is there. Just I'm taking here. Now I did, okay, I'm removing this bone. Okay, actually this is the maxilla and mandible is there. The back side some spinal cord is there. Okay, I'm removing this spinal cord. So that's why I'm doing the clapping. Yeah. Let's go for the clap value. Just here, apply here. When we are doing the applying, automatically, okay, these images you can extract from the totally object. So now 146 images, and then each image, okay, they are cropping. In the individual image, it is cropping, and the all images are stitching again. You can see here. Okay, only this much portion you are getting here. The remaining everything is removed here. Once again, go for the volume rendering. Okay, you have to remove display RMOA. Now go for the edit. Editor option. In the editor option, you can edit each and every slice, and you can remove it also. And I'm clicking OK. Then after, okay, my intention is I require the bone part, so that's why I'm selecting the bone. You can see here, and the different values you have, okay, bone, tissue, skin, okay, blood or organ, mass. Okay, these are there. Okay, these are all the predefined tissue values. Right, I'm taking the bone, and you have to go for the apply the tissue effect for this bone. So that's why I select the apply the tissue value, then apply. Here, when we are going for the thresholding here, okay, then go for the threshold value. You have to identify here. You can see here, when I'm extracting here, this bone is changing here. Then go for the make model effect. Then apply. Then go for the save option. The same here. Actually, here my threshold value is I'm selecting this one only. So you have to do something thresholding here properly. Then you can get proper images here. Again, go for the bone. So here I'm going for the STL. This HTML file I'm selecting here. Suppose I'm selecting the desktop. Suppose then desktop, choose here and save. Just bold. Just I'm showing to you the 3D model. Open with eBuilder. Loading the file here. Okay, this is our object here. And now we will go one by one here. Sir, sir. Sir, sir.
చెప్పమ్మా సార్.
Now we can go for the practice session. That means,
Practice. So all of you, please be ready with the practice session. Open your laptops, all of you. I request all the participants now. Chare is going to start again from beginning. Open your laptop and open the 3D slicer software and follow the step-by-step procedure. You have any doubt, please post your doubt immediately in the chat box. Chat box is visible to you, no, Chare?
Yeah, yes sir, yes sir, yes sir, visible.
You keep chat box and also that cell phone WhatsApp group also on, Chare, so that
yes sir, yes sir, yes sir.
So you can post your questions in chat box as well as in the WhatsApp group. So please, we cannot allow to speak because it will create disturbance. Post your question in the chat box as well as in your WhatsApp group.
Okay.
If in both the cases you are unable to solve, then you raise your hand. I'll make you the panelist. You can ask question. Right? Please follow these instructions so that we'll save time.
Yes, sir. That's what I'm telling. So here already you are having the 3D practice instructions PDF. Please open on that. Okay, here we are given the step by step here. First, we have to load the diagram data. Okay, first, okay, once again, opening my slicer software. Please, all of you open 3D slicer software in your laptop or desktop. Like that, it is opening. All of you ready? Are you like this window will be appear in your screen? All of you ready? So first, go for the load diagram data. Are you able to do?
Install and working fine. They're ready.
Oh, okay. Now, okay, import diagram data. Just click on the import diagram data. Here in your PDF also, you can see here, first load diagram data, then import diagram data. Here, okay, the arrow, red arrow mark is there. Okay, there you have to do some operation. And in the top, okay, we are written something here. Just you have to follow this PDF. Otherwise, just okay, whatever the instructions I'm giving, you have to follow your wish. Okay, now, okay, I'm choosing the diagram images from my desktop. Then after, I'm importing here. Yeah, I think all of you got this Sai Kumar data here.
In Sari, someone is telling in access they are denied something. Request access is telling. You already given access, no?
Yeah, I already given access, sir. Morning. Yeah.
But he's telling some Murali Krishna is telling even today's mail I could not download. He's telling. I don't know what is the
Yeah,
problem?
most of the people they
Most
are
of them
downloaded.
download. I will
Yes,
make
sir.
that Murali Krishna as some what I say as a panelist. Let him ask question what is exactly what is required.
What they're telling.
Murali Krishna.
Already step-by-step process is mailed to you. Don't worry, Chari. Will express step-by-step by procedure. All of please open the step-by-step process.
Murali Krishna. CM Krishna, I think. Can you raise your hand, Murali Krishna sir? Can you raise your hand? I'll make you panelist. Hello? Murali, can you raise your hand?
Sir, shall I continue?
1 minute. Yeah. He has raised. Murali Krishna has raised it. Let us make him as a panelist. Murali Krishna, you can switch on your video and proceed with what is the doubt. Please ask. 3DP 126. You are made panelist. Please ask your question. Post your question to Chari. Hello, sir. Murali Krishna. Hello? Hello? Please post your question. Please ask your question, sir. You are made panelist. Hello? Hello? Not answering. So other people are able to download. I don't know why.
Even some people diagram data loaded, sir. Some people are giving the message in the chat box.
Okay, continue, Chari. He is not speaking also. Murali Krishna, please, anything you can speak now. You can switch on. I made you a panelist. You can switch on your video and ask your doubt to the Mr. Dr. Manavachari, please. 3DP 126. You raised your hand. Okay, right, continue, Chari.
Yes, sir. Okay, thereafter, after importing the diagram images, just click on the load. Here, load option is there in the bottom.
Murali Krishna, sir, is online. Sir, can you ask your question, sir? Hello? We are unable to hear, sir. We are unable to hear, sir. We are unable to hear you. We are unable to hear you, sir. We are unable to hear. There is no voice. We are unable to hear you, sir. We are unable to hear you. Hello? Sir, we are unable to hear you, sir.
Sir, just leave it, sir.
Sir, please continue.
Sir, sir, should I continue now?
You continue, sir. You will continue. I am talking.
Okay, sir. Just here, click on load, and now the images are loading. Okay, I think all of you got this window. Anybody having the problem? Please post it in chat or anything. After importing the images, you can see this type of windows, these 3 windows. If yes or no, please write in the chat box. Sir, in DICOM file, which file need to import? Just select the DICOM file, automatically it will be import. So Anand Kumar sir. I think all of you imported the images. Yeah. Okay, sir. Okay, get next. And now we are going for the next module, volume rendering. Go for the next module, volume rendering here. Just go for the volume rendering. Okay, somebody is shouting. Sir, please repeat. Sir, how to import? Please show again. Okay. Yeah, I'm repeating once again. Please follow with me. Yes, I'm opening the 3D Slicer software. Okay, go for the load DICOM data. Okay, already I'm imported here, so that's why I'm deleting. So now go for the import DICOM images. Okay, wherever the DICOM images are there, go for that file. That means on that folder. Yes, this DICOM is having on my desktop, so that's why I'm going for the desktop. Then just choose the folder, DICOM image folder. Then click here. Just all of just choose the folder and click here. Then okay, you can import. Okay, like this will be appear on your screen, Sai Kumar, like this one. Then choose the Sai Kumar and then click the load. Now the DICOM is loading. I think all of you got this window. Taya Palu, I think, and Dhanraj. Are you able to do now? Next, go for the volume rendering module. Yeah, okay. Yeah, yeah, it's good, sir. Good, sir. Prabhu, Vivek Prabhu, sir. Okay, then after here in the volume rendering, you go, okay, choose the volume here. Then after enable to the crop, now I'm going to cropping some images, so that's why I'm choosing. Then display ROI. The ROI means region of interest. Okay, now the crop images. This one, this is the box all branch the cropping. Okay, this is the region of interest, and okay, this is you can see the 3D model. Yeah, I think all of you got this one. Please post it something in the chat box, yes or no. Then we can go for the next step. All of you got this one. Please post it in the chat box, yes or no. Any problem is there, please post it. Then we can rectify. Okay, thank you. No, from Madhu sir. Yes, sir. Yes. Yes, sir. Reach it up to this survey. Okay. Then you have go for the choose your region of interest. That means what you require here. I require the CT board. Okay, just go for the present. In the present, just you have to click it here. Okay, here you can see different type of windows are there. Here in this the third one, the CT board option is there. In the third one, you have to click. Just click it here. I'm repeating once again. You just go for the present. Just you have to click it here. In the different icons you can see here. The third one, the first third one. This is the CT board. I require the CT board, so that's why I'm choosing the CT board. Then I think all of you got this one up to CT board. Now then after you have to thank you, sir. Thank you, Rupesh, sir. Okay, then you have to crop it here. That crop means so here this box is there. Here just you have to pick this point and drag it here. Okay, like that one. So wherever which object is required, how much volume is required, that you have to extract by using this crop window. Here, three views are there. In three different views, you can extract, you can go and you have to pick this point and drag it. Whatever the region of interest is required, that much you have to do it here. I require this is only this much only region of interest is required, so that's why I'm picking this point. Okay, the three sides have the three windows. The line not appearing means you have to here the symbol is the crop symbol. Just you have to click it here, the right symbol. Then you can get these lines, this box. So I require only this board. So that's why I'm copying this remaining images one. So now I'm choosing, okay, from this total maxilla, I'm removing this spinal cord portion. Thereafter, okay, here we are choosing the CT board, but you have to adjust here. Okay, here you can see this bone is having some tissues. So you have to remove the tissues. So that purpose, okay, here shift, okay, this shift symbol here is there. Here, some cursor is there. Okay, just you have to stretch it. You have to move it from left to right. You can see here now some bone is visible. You require only bone, so you don't require any tissue. So that's why you have to increasing the threshold. And how you have to increase the threshold? Just you have to between this shift icon here. This okay, wherever the cursor is moving, there you have to click it and drag it here from left to right.
Chari, one person is telling images are not getting inserted in the WhatsApp group. He has put.
So 1 minute, I will check. Sir.
Paul, I think. Images are
Images
not getting inserted.
Help. Just you have to import. It came, sir. Then the next step is the import.
Import.
Sir, Paul, sir. Okay, you are reached up to now here. Okay. Up to now you have reached it. Then you have to load. Okay, here the load option. You have to click on the load. Automatically it will be load. Then you can get this window. Sir, Paul, sir, please click here on the load here in the bottom symbol. Bottom you are having the symbol loads. Just click on the load. Then automatically it will be load in your software. Then you can get this window.
ఒకసారి చాట్ బాక్స్ చూడవా, చాలా మంది క్వశ్చన్స్ పెడుతున్నారు.
Okay.
Let us see. Vivek Prabhu, 4 split screens arrived, sir. He was telling.
So, sir,
Okay, that's no issue. Okay, but Rupa Tulasi. Okay, unable to load. Shubham Bera, unable to load. I don't know what is the problem.
Crop with lines not appearing, sir. What should I do? Okay, for this one, Prabhu M, here enable symbol is there. You have to click on the enable symbol, then you can get the crop lines.
Sai Paul wants to make panelist.
Crop wall or crop white line not appearing, sir. What should I do? Okay, this is over. Next, sir, 4 images not appearing. Okay, good. Sir, 4 images are not appearing.
If Chidambaram says if you press volume, it is getting closer. Volume why volume is telling? I think I'll make some of them as panelists. Let them interact. Rupa Ghosh. What is her name? Rupita Ghosh, 3DP 020.
Sir, images inserted. Okay, after that, just wait. Remaining people are asking. Just wait 2 minutes. Okay, we will solve remaining parts.
I'm making this Sai Paul as a panelist. I'm making it.
Yes, sir. Just give to
not accepting. Yeah, Mr. Tai Paul, you are made a panelist now.
Thank you, sir. Yeah. Thank you, sir.
Please switch on your video and you can ask the question, please.
Sir, actually, I am having some network issue. That's why I will be able to talk from here. Okay.
Please, sir. Please
Sir,
ask.
I have inserted the images right now. Actually, I was facing after clicking the load, the images are right now here. After that, we will be going to the decom, and there we can go for the volume rendering.
Yeah.
Then after that, here it is telling to select a volume.
Yeah. Then volume. Okay, go for the volume rendering. Then after, click the volume here. There's an eye symbol.
Yeah, but sir, actually, when I'm clicking the volume rendering, here it is telling select a volume, but others parameter, that's the volume, input, display, all this thing, they are it is not working. When I'm clicking, it is not working. I don't know why. Means it is something. I'm showing the image.
Are you inputting images? Are you inputting images like this? Okay, whatever the images are seeing.
Yeah. Images are there.
Images are there,
Yeah. I'm just posting it.
Then go for the volume. Madam,
sir, I'm clicking the volume. Okay, but the thing is that you can see in the image in the WhatsApp group that it is not working. Means I'm clicking it, but it is not working, sir. Means all that are blur, like means light color means I've just posted right now the figure.
Yeah.
Image.
Let's go for the volume rendering module, madam. You are going in the diagram images. You have to go for the volume rendering module. Here.
Volume rendering model. Module.
Here, okay. Just you can see in the my cursor is moving. Here you can select the volume rendering module.
Okay.
Still now you are in the diagram module.
Sir, I have clicked the volume rendering. Then it is not coming, sir. I don't know.
Sure. Okay, just when we are clicking the volume rendering, okay, like this window will appear. Just check once more. So you
I don't
imported
know.
the image. You are imported the images. That's
Yeah,
good.
yeah, I have completed the images. Now, sir,
Just
first
go,
of all, you tell me.
let's go for the volume rendering module.
Okay, sir.
If Rupa Tulsi have some question, I made you a panelist now. You can put a question to the speaker,
Okay.
please. Rupa Tulsi.
Okay, you can see, madam, here. Okay, now you are in the diagram module. Go for the volume rendering module. Just click here, volume rendering. Automatically, it will appear like this.
Yes, sir. I'm clicking volume rendering model itself, but still here it is showing help and acknowledgement. After that, under the volume, there is given select a volume. That option is visible. But rest other all the inputs, volume, display, preset, shift, crop. I can see all this, but they are not working in my software. I don't know why.
Madam, you have 32-bit version in OS or it's 64-bit?
It's 64, sir.
Okay.
When you install the software, everything is perfectly installed or any problem?
No, sir. It is perfectly installed. The step that you have provided me, I have installed yesterday
Please,
also.
please put what you are getting on the screen WhatsApp to in the group. Sir will see
Okay,
and tell.
sir. Okay.
Please put that what is exactly happening because we cannot see your screen.
Yeah.
So you please put that one.
Just select the
Sure,
volume
sir.
rendering module, madam. Select the volume rendering module. Just go for here and go for the volume rendering module.
Okay, sir. Wait here. Sorry, okay, sir.
Yes,
Let her do it fast.
Yes, sir. Yes, sir.
Let's go a little bit slow because
That's
it's the
why I'm
first
telling
time. Most of the
Sir,
people are doing for the first time.
Yes, sir.
I have posted it, sir.
Yeah, I will see, madam. Yeah, now it is coming, madam.
No, sir, it is posted by some other person, that is Rupa Sharma. Actually, what I have posted, my name is Tia Pal. So where I have posted it, there you can see.
Volume rendering. Okay.
Yeah.
Here, the select the volume is there, na? Here, in this one.
Yeah.
Go for the select volume.
Select volume, so which one should I select? That is 255 filtered image?
255 images. 255
Okay.
filter images. 255 filtered images you have to select, madam.
Yeah, it came, sir.
Then, okay. I think you got it, huh?
Okay, yeah. Now, after that, sir, please could you suggest me?
Yeah.
Then what I will do?
Then go for the volume here. The volume, some I symbol is there, madam. Just click on it.
Yeah, volume.
I
Yeah, I
symbol.
have
Just click
clicked
on it.
it.
Then go for the crop. Okay, then enable. Click it on enable.
Crop, enable.
Go for the display ROI. There also you have to click it.
Yes, sir.
Yeah, go for the bone. The present is there. In the present, here you have to choose the options. Okay, the third one. Okay, you are seeing my screen.
Just a minute. Yes, sir. Once more, tell me. I have selected crop enable. Display also ROI. I have clicked.
Yeah, good, madam. Next one. Here, present option is there. In the present option, just when you are clicking here, you are having like these shapes here.
Yes, sir. So many shapes are there.
Okay, sir. The third one, CT bone is there. Just click on it.
Yeah, city bone. Clicked, sir.
Okay, then here, there's some boxes are there. That box is.
Yes, crop box is there.
That you have to adjust how much volume is required. If suppose you are not adjusting, also no problem. Okay, you can get volume. If you want, you can do it. Thereafter, go for the shift here.
Sir, one thing I would like to ask, for cropping purpose, if I put the pointer on that particular point, then we can crop it.
Okay. You have to click on that point and you have to stretch it. That means drag it.
Sir. Okay.
That is the method only.
Okay. After that, sir?
After that, what here shift symbol is there. In the shift, you have to adjust the threshold value.
Okay.
You have to move the cursor here. Just.
Okay, sir. Okay.
Okay, here.
Thank you, sir.
You can, here something here. When you are shifting here, the bone will appear. If you are very high is there, you can see nothing bone is there. Like that, you have to play something here.
Okay.
I think one other person, Siddharth, we can group has put. If I press the volume, the software is getting closing, sir. And this one person, I don't know, latest he has put. If display ROI is selected, image is disappearing. If it's clicked off, image appears. That's what you said.
Yeah. The region of interest means that's one only.
Yeah. If display ROI is selected, image is disappearing. If it's clicked off, image appears.
Yes.
Sir, one more question I would like to ask, sir. That is,
Yeah.
whenever we are shifting the cursor to the extreme, all the
Yeah.
bones are getting disappeared. Means
Yeah.
this is why it is occurring. Means what is the
Yeah, that is the
action means
thresholding,
of
madam.
this?
Okay, thresholding means okay, we are selecting the very high density. Yeah, when we are selecting it.
Okay.
So okay, when we are
Yesterday we have myself and sir told them, madam, threshold
Yes,
means
sir.
nothing but when you take the image, you have pixel values, right? So
yeah,
each
yes, ma'am, yes,
pixel, each image has got pixel has got some brightness. That's called Hounsfield units they measure. So if bone has got highest brightness, so you have to select that value, then other things will disappear. That means they'll become zero. In electronics, they call 0, 1, no? That's what
Yes,
happens.
sir.
That's what Shari is explaining, you know, same
yeah,
thing.
yes, yes.
Okay, sir.
Then go for the crop volume. Here a converse is there. In the converse, go for the crop volume.
Yes, sir. We are went
Here,
here.
thereafter, here go for the apply here. Here apply symbol is there. Go for the apply. Now here,
Sir, 1 minute. I cannot see the apply. Where? Just a minute. Volume information. Sir, in my portion, I am able to get this one advance. I've got there. I've got linear also, but after that I have got data prop.
then you can visible the apply also, madam. You can see here apply here.
Yeah, sir. Apply.
Apply you are seeing here.
Okay. Yeah, I have clicked it. Apply.
Hmm.
The cursor is just rotating.
And now it's going up.
Hmm.
If you want, you can choose some your like this one, and you can move it based on your whatever the region of interest is required. That is you have to do. Think here.
Okay. Actually, it is taking time. Some apply. It's
Yeah.
still now rotating.
Yeah, it's taking some time now.
Thank you, sir.
High-end image files, madam. That's why they will take time.
Yeah.
And Miss Rupa Tulsi, you want to ask some question? Please ask. Taipal,
Yes.
your madam, yours is over.
Yes, sir. Yes, sir.
So I'm making you again a participant because okay, done now. Miss,
Sir, one more thing. After applying, I did apply, but again it went. Nothing came. I don't know why.
What happened, madam?
Sir, after clicking apply, what should be the my that images came right now? Nothing to do anymore, no?
Okay, that means here just you can see here. I will show you here. Just you have to adjust, madam. This when we are applying. Okay, before going to apply, you have to adjust this cropping.
Okay.
Maybe you are not did any cropping, so that's why it is showing automatically same images.
Okay. Means I have to initially I have cropped it, sir. Again I have to crop it.
Not necessary. Not necessary. Just once is over.
Okay. Then, sir, it's okay, sir. The images came. Yes.
Image came, no?
Okay. Thank you, sir.
Next, go for the same volume rendering.
Volume rendering.
Next, this remove this volume symbol and display ROI also.
Just I will remove display ROI.
Volume and ROI, display ROI.
Okay.
Okay, so this two symbols we are going to enable, disable.
Yeah.
Then go for the editor. Legendary editor.
Just a minute, sir. Sir, editor option. That is
Okay, in the in the module, okay, you can see, madam, here the modules are there. In the module, you have
Yes,
to go bottom third one.
Yes, sir.
You
I
can
have
see
done. I've
in this
done
one.
editor
Yeah,
also.
editor. Okay.
Then it
Okay, now
came
here,
generic anatomy color.
color.
Yes,
Okay,
sir.
here that is automatically choosing the anatomy, which anatomy is required automatically. Then click
Okay,
here.
okay,
Okay.
okay.
Okay, I think all of you got this one up to now here. Any problem is there still now?
Sorry,
Okay,
someone is
Yes, sir.
asking. Please repeat crop volume step. Rahul Patel is asking.
Oh my God. Okay, I will do one.
Again, same thing. I think you have some already explained several times. Otherwise, we'll be staying here only. We cannot complete. One thing I want to tell all the participants is we are trying from our side the best. So sometime now you are doing first time, you'll get these issues. Definitely, all these thing is getting recorded.
Okay,
So
if anything, you can contact me. Then I will help you.
you will
Update.
directly contact you and you will also give this clipping in the Atal portal also it will be placed so you can see it next time also and ask. But anything specific, Rupa Tulsi, please ask
Yes,
first. Please go
yes,
ahead.
sir. Yeah, yeah. Good afternoon,
Can you
sir.
switch on your video, madam? Can you
No,
switch it
no,
on?
sir. I'm actually outside.
Right, okay, please.
Sir, everything I got, what you have told, except the
Ma'am.
extreme right corner, the
Which one, madam?
combined figure. I didn't get that. Same thing.
Okay, madam. No issue. After
No
still files
problem.
editing, no problem. You can get it.
Yeah. Then okay, sir. Thank you. I got everything.
Yeah, yes, madam. Any issues are there still now?
No, sir. No. Only that extreme
Okay,
right
ma'am.
figure I didn't
Okay,
get.
yeah. After converting the still file, you can see, madam.
Yeah, sure, sir.
I think everybody's got these images. I think, huh?
Yes, sir.
Yeah. Thereafter, go for the threshold effecting here. This fourth one here. From this bottom fourth symbol, you have to click it. This is a threshold effect. Here, once again, I'm selecting the threshold value. And where you require here, I require only bone. Suppose this, I only require this bone. And this bone also, you have to change here once again. Okay, here only I require, okay, I'm selecting here, see here, totally is showing this bone density also. Just now I'm moving here, you can see here, you are getting only bone. Suppose I'm moving here, no bone here, you can see here. So like that you have to apply, okay, based on the density value, it is choosing the thresholding effect. Then after,
Sir, after clicking threshold effect, then what we are going to do?
okay,
The
just,
bone, how we are getting the bone?
yeah, okay, just go for the bone here. The label option is there, in the label. Okay, you have to click it here. Then here, so many options are available here: backbone, tissue, normal bone. Just a second. Okay, 0, 1, 2. These two you have to select bone.
Sir, here in this particular in my this one, after clicking the threshold effect, it is showing the active tool as threshold effect. But after that, the parameters that you are getting, that is level, bone, all those things, that is not
Yeah.
visible in my. It is not visible here.
Are you choosing this fourth option, madam? Threshold effect.
Yes, sir. I've clicked threshold effect, and it is showing also active tool as threshold effect. But after that, I'm not getting that things that you are able to get here. That is means like this. Just a minute. Yeah.
After this,
I got.
Yeah, yes, madam. Then after you have to change this cursor, madam. Just you have to move it left hand edge. Then
yes, sir, we did it.
Yeah.
Okay.
Then here, click apply.
Yes, sir. Done. Apply.
Click apply. Then after go for the make model effect. Okay, from the bottom one. Okay, we have to choose the make model effect. After applying the threshold value, whatever the model is there, that model we are making. Just click make model effect.
Yes,
Then
sir.
once again, make model effect, second one.
Yes, sir, we did it.
Then once again, apply option.
Yes, sir, done.
Okay, then go for the save.
Sir, save, where is the cursor?
Yes, save.
Okay.
Save. Yeah, bottom one.
Mhm.
Then okay, here you can see here the bottom. Now okay, just here the last top the bottom extreme bone.vtk is there. Bottom extreme
Yes.
bone.vtk. You are seeing my my screen.
Yes, sir.
In this one, you have to choose the different poly data, XML, STL, poly, and .obj file. Okay, then you have to choose the STL file here. Then you choose the save. Where you have to save that, you have to choose it. Just I'm going for the desktop here. This one I'm choosing bold new. Then here click save. Yeah, I'm saving the STL file. Okay, if you want, you can save the OBJ also. Whatever you want, you can do it. Then click here save. Now it is saving. Okay, you can see bold new. Okay, that is I saved on my desktop. Just I'm opening with some 3D builder something.
Sir, in my portion, I am able to see CT bone, that is dot extension file as VP. Volume property it is coming. Should I change that one?
STL also coming, madam. Just check once.
No, sir, it is coming volume property text and volume property again.
You can see. Okay, this is my bone. Okay, this is I did here. This is my scan. So what I did here. Okay, if you want the nice one and you have to go for the edit, and each and every layer you have to remove it and apply the threshold value. If you want, you can spend some half an hour. You can get the proper model. Just here I'm showing to you just rough model how we have to convert that diagram to STL. I think all of you got it now. You will generate the STL file from the diagram images. Got it, sir. Okay. Any issues? Yeah, good. So almost all okay. So many people all got it. So they are imported in the software also. Some people are open in the CURA also.
One after the other, they have to do not say, okay, your computer system will crash. High-end softwares, please, after this one, you open CURA. Don't open both of them at the same time.
Sir, I think is it enough, sir? I think this is enough.
This biomedical modeling enough. CURA, that slicing, just you show it.
Yes, I will
That doesn't take much time, I think. That doesn't take much time.
Within 10 minutes it will finish, sir. This is having so many steps. Within 10 minutes we can finish the that 3D slicer.
But the biomedical modeling, I think it's 4 only, no? If you can,
you
can spend some more time. I told them, any issue, you can stay up another half an hour, share it, 10-15 minutes.
Yes, sir. Yes, sir. First we will finish the CURA also. Then.
So now the biomedical modeling is done. Got the 3D STL file, sir. Thank you, Prabhu. Got it. So
almost on
I want to say many other people. The one person, Raghu Babu, has already completed, shown the figure. I hope you see the WhatsApp. Sorry.
Yes, sir. Yes, so many people. Nearly
Okay.
10 people they did, sir.
Mm-hmm.
Here we shared one PDF file, sir. Okay, that means the series size of practice instructions. Each and
Yeah,
every
yeah.
step is there, sir. Okay.
Yeah, we are given.
We are given each and
Someone
every
is
step is
asking,
there.
Manachari,
Yes, sir.
some participant is asking, what is asking is, sir, how to re-edit the model? Already you have developed the model, how to re-edit it? That is his question.
Okay, yeah, that is the different software is required once again. Now in this one we can't do.
So you require different software. Can you name some of them? What are software is required?
Yeah, thematic software is required.
Dramatic. Right.
Yes, sir.
Shubham Bera also completed, also done.
Here in this only we can extract the diagram to STL only. STL.obg of the file only.
Someone said, got it, sir. Based on practice, I believe we can improve the threshold and cropping also. Yes, you can do it. Any practice will make a man perfect. So
Yes.
Rubita Ghosh also completed. Completed, sir. Thank you. She was
Okay. Okay. We
So
are
you're done.
very.
Good job. Now
Okay.
continue with
Now.
your next target. That is your STL file slicing.
Yeah. Yes, sir. Till now, okay, we are explained 3 times in this session. If you want, okay, here we are shared the PDF file, series size of practice instructions. Just you have to read and you can do your own in your house or in your home. Just please follow that PDF file. Here in the PDF file, I will explain to you once again, just within 5 minutes. Suppose those are stuck on anything, just you can check here. Okay, first, okay, we have to open the diagram images here by load the diagram images. Okay, here you are the red mark is there. Here you have to click it. Then, okay, the import diagram images option will be appear. Then after you have to click in the import diagram images. And okay, wherever the diagram images are there, that diagram images you have to choose the file. Then after choosing the file, just click it import. These diagram images will import. Okay, you can see this. These are the diagram images. Then click the diagram here in the file diagram images. Then go for the convert. In the load here, you have to click in the load. Okay, everything we are written. Select the required diagram images. Click on icon here, like below, and then click on load. Then click on load. Just you have to follow this PDF. You can able to do your own in your home. And then okay, these images will be import in your software. Then after these 3 different views you can appear in your screen. Then go for the volume rendering module. In the volume rendering module, just go for the volume. Just this when we are clicking the volume, the volume will be appear. Then after go for the enable, the crop enable. Okay, when we are clicking the crack enable, these boxes will be appear. Then you are adjusting. Okay, you can make a cropping. The cropping means normally the photo also we are doing the cropping. Same thing here. The images we are cropping. That all the images we can do one at a time. That is the difference normal to here. Then after display ROI, whatever the region of interest is there, that is you can see in the 3-dimensional view here. This you have to enable here. Then after go for the present. In the present you can choose the different tissues. Okay, my interest is bone, so that's why I'm taking the CT bone. Then after okay, you have to apply the threshold. Okay, this is a cursor is there. This cursor, okay, you have to move front and back. That means the left side and right side. When it is moving the left side, it is taking the less threshold value. When it is moving the right side, it is taking the higher threshold value. So when it is moving, automatically our 3D image also changing here. Just you have to check and you have to stop it to moving this cursor. Then after go for the cropping here. You can see here. Just you have to adjust the boxes. I require only this portion only. I don't require this spinal cord bone part. So that's why I'm choosing only this area. So this just you have to click on this points and drag it where it required. Okay, the 3 sides are there. In the 3 sides you can do And here also you can do. Okay, you have to adjust yourself which board you require. Thereafter, click the apply here. Then applying here, automatically whatever the cropping image is there, that image is only appear. You can see the previous window, the total image is appearing. Now here you can see only the cropped image is only appearing here. Next, go for the volume rendering module once again, and you have to disable the volume and display ROI. Then go for the editor. Go for the latency and editor. When clicking the editor, okay, it will be this window will be appear here. This one, this pop-up box. Okay, here it is asking we have to do some volume. It is asking. Okay, just then we have to click the OK. Now here, when I'm clicking the OK, this image will this window will be appear. Here you have to choose the label type, the tissue type, which tissue you require. You require the bone, you require the skin, you require the bed. That is, you have to choose. Now I require the board, so that's why I'm choosing the board here. Just click here on the board. Okay, you can see the board. Then you once again you go for the thresholding here. In the previous case, in the normally 3D volume rendering, we did the thresholding. Here for the volume region effect also, we have to go for the once again thresholding. So go for the click on the threshold effect. Thereafter, adjust the threshold value here. Same thing here also, when it is moving the left side, the higher the low density. When it is coming the right side, the higher density. Just you have to move this cursor, then you can able to find the board. Thereafter, click here, apply. Next, go for the make model effect. Now you are applying the threshold value. That apply the threshold value model, you have to make it. So that's why we have to choose this option. Make model effect, then click apply here. Once again, click apply. Okay, then okay, like this will be appear in your three-dimensional model. Then go for the save here, save option, and where you have to save, that is you have to choose here in this one. Then here, okay, the bone is there now, just you have to click on the bone. Okay, you can see here polydata, XML, STL, poly, and .obj. These 4 file formats you can save it. So I require the STL file, so that's why I'm choosing the STL. Then click the save. Okay, where you have to save, that also you have to choose. Then you can get the model. Okay, that is you can open your 3D slices of any 3D printer software. You can visible. That is the procedure to make a STL file from the diagram images. I think everyone got it, na? Sir, shall I continue for the next term?
Sorry, continue for the next session. STL file slicing, you do it, please.
Yes, sir.
Already no questions are there. So everyone, almost maximum people got that done, completed their job.
Yes,
so what we request all the participants in future also will be conducting exclusive sessions, biomedical, everything, FDP program 2 day, 3 day. On that you are going to have, we'll be like this, what Chari has done, we'll do that online, explain. Then we'll give some exercises because now we are short in time. Then that is exclusively only for this. We'll give exercise, we'll give 1 day time, next day again you come back, do it, then we can have more practice makes a man perfect, right? Thank you for your cooperation. Please, Chari, continue. Next.
Yes, sir. Next. Oh, sir, my PPT is appears. Okay, I'm skipping my PPT. Just I'm explaining how we have to import the So just here, okay, just open your CURA software here.
All of you open your CURA software, please. Now we are going to STL file slicing using CURA. It doesn't take much time. It is not that difficult like this biomedical modeling.
modeling. So that's why
Please.
now I will do it myself. You have to do it yourself. It will be finished.
You little bit be slow, Chari, so that you will understand.
Yeah. Yes, sir. Yes, sir. I'm very slow.
All of you be ready. You can open your laptop.
Yeah.
The step-by-step procedure is also given to you in we have sent the file. Step-by-step procedure is given to you. Please, you can open the file and see it.
Just all of you open your CURA software. So almost all so many members are did, sir. I think very happy.
They are done. They are done.
Yeah, they are keeping in the WhatsApp group.
One small announcement to all the participants is some of you are attending this program, you are seen in the list, but you are not filling up the feedback form. So if you simply attend and don't fill up the feedback form, you will not get attendance. You have to compulsory fill up the feedback form of each session. I am seeing here, some of you are seen here, but they are not filling the feedback form of each session. Please fill up. That will consider for your attendance sake. So not only feedback form, this both will consider and give attendance accordingly. So all of you have to attend. So we are going to take from WebEx, and also you are going to have from the Google form that we are posting in the chat box for getting your attendance. So feedback for each session. So you have to fill up that and submit compulsory. Right. Thank you. So Shari, you can proceed.
Yes. Here, just here in the top left, okay, you can see here.
There is one question, Chari. There is one question. Dr. K. Sri Krishna is asking how efficient are free online .nrd to .stl converters such as www.embody3d.com. Something is there. The chat box he has posted. Dr. K. Sri Krishna, I think, is a dental doctor from Ghaziabad.
Oh. Where is it, sir? The last chart.
Generally, free online converters will not be as efficient as the professional one, but still
Yes, sir.
it may serve your purpose. I think.
Yes, sir. Actually, compared to Mimics, this STL file also not good. When we are doing in CSI, sir. The Mimics, you can get the proper STL file.
Because it's a very high-end commercial software, costly, so that's why you get all those.
Yeah, yes, sir. And very smoother and accurate model you can get compared to this TSI, sir.
Okay, please continue, sir.
Yes, sir. So just go for the file here. Just click it here. Just desktop. So here already I shared one STL file in your mail. Just open that STL file here. Just STL, select the STL file, then open it. Here, this object is.
Sir, once more, will you repeat, sir? We have opened the Ultimate CURA, that software. How again you are inserting? Just once.
Yeah.
Please identify who is this? Rupa, Miss Thai. Okay, type.
Yeah. I'm repeating once again, madam. I'm repeating. Yeah.
Sure, sir.
Here, the top left corner, here, there's one book symbol is there. That is file symbol. Just click on it. Okay, then you have to choose your STL file. Okay, morning. Okay, in the mail we are forwarded one STL file. Just pick that STL file.
Okay, sir.
Then open it.
Yeah, it is open.
Yeah, this STL file is larger compared to our model. Okay, this our base plate dimensions. So that's why we have to go for scaling something. So here this is the X is having that 100, Y is 1. Now we are going for the scaling. Just I'm choosing this one. The scaling also we can do here. How much percentage we can reduce, that we can do it. Suppose I want to require in the 50% reduction. Just type it 50 and click enter. Then you can do the scaling. Suppose this is a uniform scaling. Suppose I don't require the uniform scaling. I require the scaling in only x-axis. That also is possible in this one. Just click it and do it. You can see the x-axis only, the scale is up. So, but the dimensions are changing. So always you have to choose the uniform scaling. Then you can get the good model. Thereafter, you have to move it just. Okay, and this is also okay by using. You can move it and you can change the scale. That also possible with using this model. Okay, this is having this model is having outside of the bull value. So that's why I'm choosing inside here. Just click the arrow mark and you have to do it. This is the z-axis, this is the x-axis, this is the y-axis. Okay. Here in the z-axis having some gap here. So just I want to fix on the page. Just z I'm keeping the 0. Yeah. Now this is also having the outside. So that's why I'm moving inside here. This side. Now you can see when the yellow color is coming. That means okay that is inside of the bull value. Okay. That is about the now scaling and setup in the build bridge. Now, if you want to rotate it. Suppose I want to rotate this is and suppose in the 15 degrees angle. We can rotate it by using this is the x-axis, this is the y-axis, this is the z-axis rotation. What you want, you can do it. Just I want to reset my object. You can do the reset also. That feature is available here. Okay, I want to. This is the bottom. Just directly you can click it here. I want to flip this. That means this is a flipping. This symbol is a flipping here. Okay, then after, okay, first you have to choose the model in the build value. Then after go for the slicing here. In the slicing, where the total entire object is dividing into small number of layers. Just go for the slicing here. Click here slice. Now the slicing is going on. So this is very big part, so that's why this much time taking. Just save to file. So wherever the required that you have to save it. And here, okay, we have to save in the STL file, ASCII and binary, and TMF file also nowadays. Okay, 3D printer, some 3D printers is useful for the TMF file format. That also you can save it. Okay, the FDM printers has majorly require the G code. Okay, some printers, the color printers has require the .obj file. So that also you can save. Yeah, after this one, you have to save according to your requirements. Suppose I require the FDM printer, so that pricing. So that's why I'm saving the G code. Then after you have to click on save it. This STL file. And when you are open with your notepad, you can see. Okay, this is extrusion with a nozzle here, and okay, these are the x and y z dimensions, x y dimension, and this is the the material extrusion. How much material is required? That is this one. So G1 is the linear interpolation. That is the G code. I think you know. Okay, like that in each layer. Okay, how much extrusion is required? How much traveling is required? Everything is you can get from this 3D Slicer software. This file we are sending to the machine just by your USB or by cable, anything. Then automatically 3D printer will be print the model. Okay, here this preview. Okay, I want to see some preview. Yes. Here, suppose where is the support material is there? Where is the model material is there? You can see here. This is the yellow one. It is showing the support material. This red one is the model material. Suppose here some halo portion is there here. How we have to build some supports are required. So that's why automatically the software will be generate the supports here. You can see here. This is the support material. So you can see each and layer by layer. Okay, now okay, I'm giving a small example. In the NDT test, they are making the CT scan of that object, and they are converting the STL file. Then they are checking each layer, okay, like this one. Okay, each layer, suppose any holes are there, any blowholes are there, that you can identify when we are clicking here one by one. You can see 1, 2, 3. In each layer, you can identify here. So here you can see this is a model material, this is a support material. Okay, here there is enough of, I think. Okay, then okay, this is over. When we are going for the position, the printer, okay, first you have to give the printer. Okay, first before going to this software, first attach your printer. Okay, which printer you are having? Suppose Ultimaker S5 I'm given. Suppose if you want, you can add the printers. Okay, this many printers you can connect by using your Ultimaker CURA. Okay, these are Ultimakers, and okay, you can see okay, so many 3D printers support this CURA software. Okay, suppose this I'm generated the G code for the Ultimaker CURA. Suppose I want to do some you build 3D printer. Okay, you have to select and add it. Then you can generate according to your machine. But almost all everything is same. The sizing and everything is same. And okay, settings is over printer. Here some options are there here. Okay, you can choose the wall thickness. Okay, here I am taking the 0.8 mm. Suppose you want to choose 0.2, 0.3. According to your requirement, you can choose your file. And here I am taking the wall thickness draft is 0.2. Suppose if you want very fine finishing is required, you can choose the 0.1. Okay, whatever the requirements is required and whatever the object is required, based on that object, you have to choose these options. So here you are having so many options. You can see your wall thickness, wall line contour, and top and bottom thickness, and how much speed also required. That also you can get. And infill percentage, how much about infill percentage is required inside. That also you can control. So suppose you require the full density part, you have to choose the 100. And you can infill type also. You require the line type, or triangle type, and cubical type, or octave type. So okay, that also you can choose. Okay, everything okay, you can choose, and everything will be reflect on your time and your quality of the object. Okay, this is for the machine setups. These are the machine setups. This is the part setups. So I think it's over. Any problem while during your practice?
Sir, please repeat the slicing process. I think Sir has already explained slicing. Where you want Mazaruddin was asking, please repeat the slicing process. He was asking.
Yes, I'm doing so within 1 minute.
Please, Mazaruddin, please see. Abhishek Tevta, you are unable to slice. How to get back to initial position is Anil Kumar is asking.
Yeah. Okay, just you have to open. Okay, just open your Ultimaker CURA. Then go for the file. Then select your STL file. Just I am imported STL file from outside. This STL file okay is very big, so that's why I'm doing some scaling. I'm doing some 50% scaling with uniform.
Yeah, interesting question. Vasist, I have opened the skull STL which we made right now in CURA. I can see lots of tiny bone pieces and most of the bones aren't connected. They are all in the air. So what are the things need to be processed after getting your medical STL file? Yeah, that is, you are not done any error removal process is not done. That's only STL file we created. Afterwards,
Yes.
as Chari was saying, there are other softwares which are used to remove those errors.
Yes, sir.
Right, Autodesk Mesh Mixer, and as you were telling that, what is that? Other software.
Thematic is a very good actually. Thematic software.
Thematic, the thematic software that you do.
So that's why I'm choosing the different STL file. Okay, maybe the how is coming.
It is taking 2 days to print. How to reduce this, sir? Is the size will be bigger when the printer will take 2 days. Sometimes
Yeah, 2
it will
days,
take 3 days also.
Yeah.
You have to give it and it will continuously print. That's how you have to do 3D printing. Got it. Someone, Srinivasan got it. Can be done in 10 hours, 2 minutes to produce the part. Actually, we can further we can extend. We may change the orientation. How much is the build time? That is another exercise. We have bigger things,
Yeah.
but I think there is not sufficient time. Whatever
that's
is
why
possible
I'm-
within the given time, we have done the things.
Yes, sir. That's why
Missing
I'm.
that of the skull.
Yeah, that's why I'm reducing that one. Okay, we have to change the orientation. We have to calculate the time, and we have to change the infill percentage. We have to change the layer thickness. Everything you have to choose based on your requirements.
Yeah. So missing that of skull means again we said you have to use repair algorithms, and that softwares like you guys thematic and all those software you have to use. And I think I explained in the beginning in my biomedical modeling that you have to do that and use different softwares for getting the final part before you print it. So one question, Vamshi Krishna, how to understand infill patterns for turbo machinery design requirements? Example, impeller. How to understand infill patterns for turbo machinery design requirements?
Infill percentage. Can you? I think you can explain.
I think he's asking hexagonal and other patterns are there. No,
Yeah.
which pattern?
Yes, sir. No, sir. Okay, the infill percentage means the material filling percentage. Suppose you require the 100% filling means, okay, you require the solid part, you have to choose the 100% filling. Suppose you require only shape, okay, you can choose only 5% filling also. Depends on upon your application, you can choose your infill percentage. Actually, we are forwarded PDF files. Some Himabindu, you are asking some question. Actually, we are forwarded PDF file for the procedure of this CURA as well as 3D slicer. Sir, any doubts? Anything? Sir, Shiva, sir?
Question is, to every medical implant, we cannot reduce infill, right? Okay, that depends on your requirement, medical implant requirement. As yesterday Professor M.V. Reddy Garu told, medical you cannot compromise. It's not like engineering design because it is fixed.
Yeah.
You cannot change that the bone here, natural bone is solid means here I put hollow. How can you do it? The body won't accept it. So then, depending on that requirement, the doctor will tell. Accordingly, you will do the infill and produce it. It may take
Yes.
more time.
Yes, sir. Yes, sir. I think.
Why it is showing unable to slice, sir? Rupita Ghosh is asking.
Hi, sir. Slicer, sir. Slicer. Why it is showing unable to slice? Maybe the STL file having some errors and some gaps is there. So that's why maybe it is unable to open your STL file. That is a medical model STL file. You have to repair.
Rupita Ghosh tells that why it is showing unable to slice, sir. That's what she said.
Why it is showing unable to slice, sir? The 3D slicer, sir. Actually, what is she asking?
Exactly. Please, Rupita Ghosh, please, I'll make you a panelist. Please, exactly what you want, please get it clarified. Rupita Ghosh, I'm going to make you as a panelist. Your number is what? 3DP020. Please, madam, you go ahead, Rupita Ghosh. Please ask your question. I made you as a panelist.
Yeah, sir. Actually, it is showing unable to slice. So that's why I did according to the PDF file and also whatever you told here. I'm sharing the image in WhatsApp, sir. It is coming as unable to slice. So that's why I asked.
Yeah, it came, madam. Okay, just I will show you just within 1 minute. Just choose the STL file, then click
Yes,
here.
sir.
Then after you have to reduce the scaling. Then you have to keep it on the platform. And then after, okay, just maybe, okay, this model always you have to keep in the middle, then you can process it. When it is coming the yellow symbol, then you can do process it. Okay, this is the some one defect, maybe something you are fixing here or here. Then after coming this yellow symbol, okay, then it will be good. The model is fixed in the build platform. Then go for the slice. Then it's going on slicing. Now it's did. It's completed.
Okay, sir. Actually, this yellow symbol is not coming. That's why
Yeah, not
maybe.
coming. That's what I'm telling. The yellow symbol is not coming means so you did something wrong. Actually, it is having outside. Otherwise, something you did mistake something. Okay, please do once again. When the yellow symbol, yellow color is coming that object, then it will be go for the slice. That is the
Okay,
one
sir.
indication. Okay, that is one file.
Okay, sir.
Thank you, madam. Any doubts? Any queries regarding now? After saving, can you to enter end yeah, after saving, it is finished. That file you can send to your 3D printer. Nilesh. Any queries regarding this software practice session? Sir?
Yeah. Sorry, please.
Yeah, I think it's
Zora? No queries, I think.
I think, yeah.
Thank you very much. You got an appreciation from Priyadarshini. Thank you very much, sir, for an informative and practical hands-on session. So I request any of the audience, Shari has taken, yeah, Raghubabu wants to speak something on this occasion. So Raghubabu, I am making you as a panelist. Please go ahead, switch on your video and please speak. Anyone, any other person also can speak about today's session. If you can give live feedback, Raghubabu can switch on your video and please proceed with your feedback. Dr. Raghubabu is the professor in VNR Vignan Jyoti Institute of Engineering Technology. I welcome you for this session. He is a regular participant in our session. And like a student, even though he is a very senior professor in the college, like a student is regularly appearing for our program for each and every session. I thank you, Raghubabu, for your active participation. Please proceed.
Good evening, one and all. Am I audible?
Yeah, you're audible.
Yes.
Yeah. Yeah. Thank you, Sivaram Krishna, for introducing me. So, I have attended recently so many of the FDPs and workshops on additive manufacturing and 3D printing. So here, both the subjects, one is the rapid prototyping and additive manufacturing, I'm taking for my MTech students. So in all those workshops, many sessions, people are giving the theoretical information. I think this is the only session where we had some hands-on session, practical experience on modeling of biomedical modeling, CAD modeling using in 3D printing or additive manufacturing. So Manmad Chari garu, once he visited our college, VNR Vignan Jyoti,
Yes.
for one workshop, we invited him.
Yeah. Thank you. Definitely.
Yeah, so in that also Sara has explained beautifully the concepts. Today Manmad Chari garu explained very nicely, and the PDF document which you have already given through mail is
Yeah.
clear-cut indication of how to practice the softwares in each step by step very easily.
Yeah.
So even a layman can also follow it, and you can do very precisely the components.
Yeah. Thank you, sir.
Thank you, sir. Thank you very, very much for your effort, sincere effort in sending the softwares as well as the PDF documents, which will give you the procedure for the all the participants to practice thereafter also.
Thank you.
And one more thing is, this is not only the thing, just it's only 5% of the thing. Sivaram Krishna sir knows, and Chari sir also knows.
Yeah.
So many other things are also had to know various softwares regarding getting a final component out of this printer.
So actually, Raghu, as we said, our director also said, we are going to plan an exclusive session of biomedical modeling where we have a 2 to 3 days exclusive sessions on this modeling. And I request the participants who want to participate exclusively on biomedical, we'll practice online, and then we give exercise, then you come back next day and you can share all the things. So as Raghu Babu sir said, Professor Raghu Babu has said that 5 minutes, it's only what you call tasting a small thing, but actually you are going to want to learn more, you have to practice more. Practice makes a man perfect. Thank you, Raghu Babu, for coming over. And being a senior professor, still the urge to learn the subject is high in you. So I appreciate that attitude. And thank you very much for joining all our sessions regularly. He's like coming like a regular student and listening to all the sessions in spite of the busy schedule. Thank you, Raghu Babu. Right.
Thank you, Chari sir. Thank you.
Thank you. Still, anyone wants to speak, they can tell, or you have any questions? So Abhishek Teotai, I'm making a panelist. If you want, you can speak because you are putting your comments, and I hope Abhishek ji, yeah, Dr. Abhishek from NSCI 2. I'm going to make you as a panelist. Please, Abhishek, are you there?
No.
Dr. Abhishek ji.
Hello.
Dr. Abhishek ji, you can switch on your video and you can speak, please. Dr. Abhishek ji.
Hello, am I audible, sir?
Yeah, you are audible. Please, you can switch on your video. Possible. No, we are unable to see you. He is from NSCI UIT Delhi.
Hello, sir.
Please proceed, ji.
Hello, sir. Chari, sir. Hello.
Yeah.
So it was very much informative session, sir. It was very much informative, and I had tried many of the things which you have given in the PDFs and everything. Few drawbacks were there. Drawbacks, it was not exactly a drawback. Actually, it was the thing which we have not able to do because of this platform, because of the network connection as well. But whatever the PDF you have sent, that was very much informative, sir. I'm very much pleased with this. Yes, sir. So just I want to convey this particular thing to you, that it was very much informative, sir.
Thank you.
Thank you.
Thank you, Abhishek.
Thank you, sir. Thank you, sir. Thank you, sir, for introducing and letting me say the things to sir, and thanks a lot, sir.
Thank you very much, Abhishek ji. You are also a regular participant. Regularly, you are coming to our FDP every day. Thank you for participating regularly to the program. Thank you very much.
Very much, sir. Thank you, sir. Thank you.
Thank you. So, Abhishek ji, Chari, your video is off. I don't know.
Yeah, it's coming, sir.
Your video is now it is coming.
Just sharing is stopped. Actually, that PDF is very useful, sir. With if suppose they are seeing the PDF, they can do themselves, sir.
Yeah, correct. We made like that only. No, we
Yeah.
planned this long back. I think 1 month back only we have done all the exercise.
Yeah.
So, any Rupta Ghoshji, you are already on the panel. You can speak if you want. You are putting some. Chidambaram from Chaiting, he is asking some question. Let us put in 3174.
What he's asking, sir?
You can give feedback. We can also improve ourselves, and we can further make the sessions good. So Chidambaram ji, I made you a panelist. Now you can go ahead and ask your questions, please. Hello?
Sir, my doubts have been cleared, sir.
If you want to say about the session, you can speak out.
Sir, it's a really good session. Before
You can switch on your video, ji. You can switch on your video. It's possible.
Sir.
Yeah, please. You are visible now. Thank you. Please go ahead.
Yes, sir. During my PG, I had come to know the slicing software, CURA, but this time by participating in this event, I come to know the biomedical, how to convert the model into a STL file, then to make a slice, sir. Yeah, today I learned that only, sir, and it was a good session, sir. Thank you.
Thank you.
Thank you.
Thank you. Thank you. Thank you.
Sir, one thing I would like to say.
Who is this?
Hello, sir. Sir, myself,
this?
Thia Pal.
Huh?
Thia Pal.
I'll make you one.
107.
Thia Pal, right? Please. Yeah, please go ahead.
Thank you for this lovely session we had today. So, sir, if you can provide us this training session later on also, at least the extension of this particular extension of this FDP, then it will be very fruitful for us, because being a mechanical engineer, we are working with this biomedical, all this thing. So it is really an interesting one. So if we
You are working from where, madam? You are working where?
Sir, actually, I'm working on JS College of Engineering, which is located in Kolkata, West Bengal.
Very good. Good, madam. So definitely, madam, as we said to you also earlier, our Center for Product Design Development Additive Manufacturing is exclusively meant for training the any interested that is students and PG, research scholar or faculty, anyone on the thrust area of 3D printing. So we'll be organizing such sessions. As we said earlier also, we are going to exclusively organize a session on biomedical applications, where we'll plan 2 to 3 days workshop. In that we'll be giving an exclusive sessions only on bio, because here is a generalized one. We cannot put all the things in one thing, because we want to have good speakers here, and that's why we brought a taste of each one of you. But in future, you are going to have each session. For example, you want to have on biomedical, we'll make you to learn from scratch how to take a DICOM file, and as what Dr. Chari told, we'll put we'll give homeworks also, exercises also we'll give it to you, and you will practice. Next day you come back again, we'll discuss all those things. That is definitely done, madam. Only we require a participant interest to participate in these programs, right? Thank you.
Actually, sir, being a mechanical engineer, we are getting a little bit we are getting a lot of interest also right now, because we are aware of this aspect of this 3D printing in this means we are aware of the knowledge, but this much in details, so many doctors have given so many examples yesterday in the application section. So we are getting a little bit interest. That's why.
Actually, we are working in this area for the past 8 years. I think we first started with Chari only, the biomedical modeling in our center of CPTIP. And then onwards, I think so many doctors are working with us. Chari.
We did first case with Usmania Medical College.
Yeah, Usmania Medical Dental College, we have done it. And when he submitted that paper to the journal, he has asked us 60 questions, make another case study. So again, Chari has done after his award of MTech also. It's a good paper. It's still in the DOI, it has got good recognition. And I think that's from where we are doing this work in biomedical. A lot of doctors are involved. Yesterday, Abhishek, Abhinandan sir, and then we have MV Reddy, everyone was there. Thank you very much, madam, for your feedback.
Thank you, sir.
Thank you. So I hope most of the participants have.
Next time we will plan only Bio-CAD modeling purpose of the half day, sir.
Yeah, we'll do it. Anyone still? Okay. Now I'll be sharing the feedback link. Mr. KMD Mazaruddin. You want to speak, Mr. Mazaruddin?
Hello, sir. Hello.
Who is this? Rupta Gosha? Please go ahead, madam.
Yes,
Please.
sir. Yes, sir. Sir, in spite of the busy schedule, actually, I'm working in Yale University, Vijayawada. I am also working in the field of biomaterials.
Okay.
So
You are a associate. You are a professor there, madam. You are a professor.
No, sir. No, sir. I am an assistant professor, sir.
Okay. Okay. Good.
So in spite of the busy schedule, all the classes, after handling all the classes, I am very impressed with the session, sir, and also I learned many things. And actually, my area is like synthesis and characterization of the biomaterials, and also I want to apply it in 3D printing. For that purpose, also I wanted to synthesize the biomaterials accordingly for mainly for bone tissue engineering applications. Sir, it was a very nice session, sir, for me. I learned a lot of things, sir, and also for providing these files. It is very useful, and obviously in future I would love to be with I would like to be a part of this type of program, sir.
Definitely, we have all your database with us, madam. Whenever we conduct program, we'll let you know, and you can participate in that event. Because now most of the events are online, so anywhere you are located, also you can participate. Thank you, madam, for your
Thank you, sir. Yeah.
So Chidambaram, thankful for providing all the links of the software. There was Samir. So there were so many appreciations for you, Chari. Congratulations.
Thank you.
Everyone was so impressed. I am interested in doing research over 3D print medical application. Can you suggest me a particular area where I can proceed in specific way? As I am all doing my literature survey. Chidambaram is asking. Just now he has spoken, right? Okay. So already Chari has told you can. It is only application you have to think about and start doing work in the reverse. Find out materials required. What type of implants in that. Discuss morning topology optimization. In implant also you can do topology optimization, generative design. All these things you can think. I think Chari, anything you want to say to that guy? What are the areas you can want to do research?
Yes, sir. Yes, sir. Yeah, depends upon the doctors. We have to do design. That is the practical way.
So you can take one case study and take it as perfectly study and work it.
Yes, sir.
One case like case study.
Yes, sir.
With your PhD work, the problem of the patient should be solved.
Yes.
Okay, right. So thank you all for joining. I personally, on behalf of the organizing committee of this Atal AICT program on 3D printing and design, and on behalf of myself and Professor Sriram Venkatesh, the coordinators of the program, in the Department of Mechanical Engineering, University College of Usmania City, I thank our resource person, today's evening resource person, Dr. Manmadachari, for coming and taking such a lively session with all the inputs on how to do biomedical modeling. So because until yesterday they had all the theoretical inputs, and then now you had a practical session. I think that made them to relate very easily. So if you directly go to practical session, you will not understand. That's the reason why the session is kept after the theoretical inputs. So I hope you have You lived with the expectation, particularly after lunch. No, you made everyone not to sleep, and everyone is working and doing, asking so many questions. That itself indicates how interactive the session is there. So definitely, as per the demand of the many of the participants, they want to have more exhaustive sessions. In future, we are going to have all those sessions in which our Manavachari will be definitely a part, because he is a part of parcel of our CPDM center and also is alumni of Usman University. It is not. It is. I have the privilege to tell it is mandatory for Chari to participate in these events and be associated with us. Thank you, Chari, for sparing your valuable time and spending the time. He has actually worked out 1 month back itself. He made all the steps, files, everything he has done. Excellently has planned and sent it to me. So when I requested him to take a session on this. So thank you, Chari, for coming and sharing your ideas. Thank you very much. Thank you.
I'm
You
also
want to
thanking
say?
you, sir. Yeah. Yes, sir. Just 1 minute, sir. Sure.
No.
I'm also thanking to you, sir, for giving this wonderful opportunity to present my research area and to present my knowledge to participants. Thank you.
Thank you. Thank you. So today's the session is the ends now. I'll be putting the feedback form of today's session, last session. Please fill up this feedback form. I am going to post this feedback link in the chat box and as well as in the WhatsApp group. Please submit. All of you, please. Sir, if you want, you can leave. No issue.
Yes, yeah, I'm leaving, sir.
Bless. Thank you. Thank you, sir.
Thank you, sir.
I have posted feedback link in the chat box and as well as I am posting it now in the WhatsApp group. I request participants, some people to cooperate with me now. What I am planning now is anyone there? I want to have one help is now there is one problem with you are unable to see the other participants. The reason for that is when I am selecting view all the participants option in Cisco WebEx, it is telling network issues will come, problem like that. So tomorrow, because being the last day, I want to see that I want to use that option. Before that, I want to test whether this option will work. Will there be any network issue or not? If you stay for 10 minutes, I will send you all another link with allowing all the participants to see so that we can test now. Because when the session starts now, there should not be any disturbance. That is the idea why I have not taken that risk for the host for the past 4 days. But today I want to see whether we will be able to use that option so that there will not be any network issue. Because tomorrow being the last day, we are going to have a validatory function which will be chaired by the ISRO top person, the Dr. Venkata Krishnan is a distinguished scientist of ISRO, the topmost recognition ISRO, and also is the chairperson for capacity building project office from ISRO Bangalore. He'll be talking the last session as well as with the guest of the chief guest for our validatory function. Along with him, other dignitaries will be there. So before I select these participants, view all participants, I want to test now itself whether it will work or not. At least I require 50 or 70% who are there now to participate in this link. This is a trial. I hope all of you will agree. Please say yes in the chat box if possible, please. Within
Yes,
10
sir,
minutes, because
yes,
I
sir,
want to make all of you to see, and tomorrow we will have a group photo with all the people. That is all of you switching on your videos so that we will have an idea. So please cooperate with me. I'll be now closing this event and generating another new mail and sending it to you. Please cooperate with this, right? Thank you. Just I am ending, but I will again we rejoin another within 10 minutes. Okay. Thank you. Thank you. You're all saying yes. Thank you very much. Thank you.